I will go ahead and get started. I did go through and pick homework questions. Again, this is from the 7th edition, which is Chapter 2. This is posted to Canvas. So if you check under the announcements, it's not the most recent announcement, and it will become later and later as the semester goes. It's the homework announcement, whatever that is. And I've got all these problems just copied and pasted up there. So you've got access to them outside of just the lecture slides. Okay?
Which chapter is this? Is it the week 3?
So these exact slides are not posted as of yet. That's why you're not going to see it here. The most recent slideshow is going to have everything else that's in this, depending on how far we get. Okay? Other questions? Okay, it is important to also note that not only should you be doing homework, you should be working on memorizing. So there's that element list. I did cross that T. So that can be found under the, I think, helpful information or helpful files folder under the files subheading. You do need to have those elements memorized. You will get tested on those on the first test. Then we'll also have the metric prefixes, so you need to start getting those memorized as well so that you can then use them. If you don't know what they are, you can't use them in the conversions. Okay? So a large portion of this test, or a big section of it, is going to be doing the unit conversions, which we will be talking about in more depth today and then next week as well. Okay? Questions? Okay. Go ahead and move on. So I left some review slides up there. So the significant digits, you will be expected, given any given number, to go ahead and predict. I really should edit and fix this slide. That number should be significant digit. Okay. So if I gave you any one of these on the test, you should be able to tell me exactly how many significant digits each has. So really simple for me to write multiple choice. As long as you follow the rules, hopefully there'll be simple answers. Rounding. You do need to be familiar with what rules apply when you go through and do these different manipulations. How does that affect your end result? So if you have to round your number, you have to make sure that your answer comes out correct and is adjusted accordingly. For the sake of this first test, because you are officially getting tested on your ability to round, I will probably ask a simple order question. So by simple order, I mean probably just along the lines of adding and subtracting, or adding, subtracting, or multiplying, dividing simple numbers, so just two numbers, and then asking you to tell me what the answer is to the correct significant digits. So if we picked these, let's go through some multiple choice answers to give you an idea on what's going through my head. So first off, one of your answers would be that one right there. Okay, why? That's what your calculator tells you, right? Okay. After that, you'd probably get a sequence of other numbers. See if I can make some of these up. 1.3, 4. Let's go 1.3, and then maybe E, because I'm not feeling particularly creative today. Goats. So presumably you would be able to eliminate one of those choices, right? Which choice would you eliminate? Just checking. Should be able to eliminate goats. That makes your life a little bit easier. After that, you'll notice all of those numbers are something that a calculator would give you. So you have to know some information about how you, first off, determine your sig figs and how you would approach rounding. So we'd go through for addition and subtraction. How do we determine our sig figs? Least accurate place. So if we actually lined it up nice and neatly, so this would be a good reason to use graph paper, because you could then align those places underneath each other. That's our significant digit. Okay? So in our answer, we would need to report at least 1.33 So what does that do for us? Eliminates D. Okay, the next part is deciding what else should we include in that. Should we include the 5 in our number? Let's ignore rounding. Is A a valid answer? A is not a valid answer because that carries too many sig figs. That 5 is not allowed to be counted because it's a digit that we don't have any information about, which means A is also not an answer. We're now left between B and C. So on this first test, I can test you on rounding. This is how it would happen. I'd keep it relatively simple and address those problems as we go. So in this case, what do? Go back to our rounding rules. If our digit is equal to 5, should fix that too, or greater than, we add 1 to the last significant digit. That is indeed the case, so our number becomes 1.34C is our answer. Does that make sense? Okay. So when I'm coming up with the multiple choice answers or wrong answers, it's not just going to be a bunch of random numbers thrown in there and only one of them matches. Pretty much all of them are going to have the ability to match. So you have to make sure you understand the rules to actually decide what that number actually comes out as. Okay? So it's a little bit trickier. If you know your rules, it's not going to matter. Make sense? Same kind of thing would apply with any other sequence of numbers. Okay? I might pull out a whole bunch more digits in it or do less just to mess with your head because it's fun. Okay? When we start measuring really big or really small numbers, so we looked at our main or our base units for measurements. What do we have? Whoops. I know it's definitely not on this slide, but let's see if we can come up with them. Our base units, what do we have for length? What do we have for volume? Mass? Time? Time's a little bit trickier, but typically looking at seconds. So if we're going to go through and measure individual things, we might want to scale up or down accordingly. And if we had to do that a substantial number of places, we might want to incorporate our powers of 10 with our prefixes. Okay, so this is what we talked about on Tuesday. So applying those shifts to allow us to simplify how many zeros we'd have to include or write out in our individual number. So all we're doing is scaling off of those base units. Said that you needed to memorize kilo, centi, and milli. Absolutely. The rest of them you should have some familiarity with, but you will absolutely see these 3 show up on your test. Okay? So that's kind of the pass level. After that, if you really wanted an A, I'd probably throw in a couple questions on one of the other ones, just to see how much extra effort you put in to get those memorized and nailed down. Yes?
Are we going to have
These are the base units that I would expect you to memorize. There are more. Okay? For every shift of decimal point, you get a new prefix unit that you could use. These are going to be the ones that you're expected to have memorized. Okay. Beyond that, if it's something else, like you're saying deca, or is it hecta or is it hecto? Hecta. Those extra units are something that I haven't told you to memorize, which means on a test, I would tell you what they mean. You wouldn't have to have that information memorized. Does that make sense? Okay. Why'd that go away? And I believe we looked at our fractional notations. So we went through and evaluated the English on saying 10 to the negative 2 meters in 1 centimeter. And we could then convert that into a fractional notation, or as your textbook refers to it, a unit fraction, I believe is how they're referring to it. To me, what that is a conversion factor. That unit fraction now allows me to convert a number in meters into centimeters. Okay? If we go over and take a look at the next one, that unit fraction allows me to convert centimeters into meters. Okay, how would I know that? Well, if I'm aiming for meters, okay, if that's my answer, I want an answer in meters. Where's meters showing up, the numerator or the denominator? Showing up in the numerator, which means my conversion factor had better have meters where? In the numerator. If I shifted it, then my answer is going to put meters in the wrong unit at the end, or the wrong place. Okay? Kind of make sense? So we want to be careful with how we set up our conversion factors. We may end up using slightly different versions. Some people don't like the 10 to the negative 2, okay? Which was, whoops, I removed that slide. That was the slide where we talked about what that negative means and different ways to interpret it. We could have just as easily written these. I don't have a whole lot of space here, but for our far right one, this is the same as 1 meter is 100 centimeters. Okay, because the 10 to the negative 2 means that calculation needs to happen in the opposite of where it is. The number is currently in the numerator. So if I do 10 to the 2 in the denominator, I've now accounted for that calculation. Okay, so we've got 1 meter is 100 centimeters. Up to you how you want to go through and memorize those. Typically, most people don't remember 10 to the negative 2 meters is 1 centimeter. Okay, how do we typically memorize it? Working on my opera voice. How would you typically memorize a relationship between meters and centimeters? Probably 1 meter is 100 centimeters, not the 10 to the negative 2 part. Why? 10 to the negative 2 is confusing. Why? It has a freaking negative sign in it. Okay, so we change that so that we don't have to worry about the negative, we don't have to worry about the exponents. Does it kind of make sense? So it's just a perspective on how you want to manipulate and use those numbers. Make sure that you get those conversions down solid, however you want to memorize those relationships. Okay? So we can do some mathematical tests here. So in theory, you guys are comfortable with these. So what happens? No calculator. What's that first answer? 3. How do you know that? What we're saying is 6 divided by 6 is 1, so we get 3 times 1. 3. Nice and simple. What happens in the next one? Okay, we're evaluating our numerator and denominator. So what we've done is effectively condensed those units. Our 3's cancel, and we get 12 over 1, which is just 12. Last one, a little bit trickier. We can cancel that 4 with something in the 16. What is 16 equal to? 4 times 4. We can cancel one of those 4's. And what we'd be left with is 3 on top and the 4 underneath. We've got 3/4 as our answer. So mathematically, with our numbers, they're relatively simple. We can try and break these down into individual pieces and process them. Okay? Taking a step further, we could just punch it into the calculator and get an answer and not have to stress at all about fractions or any of these manipulations. Okay? And that's what I would guess a lot of you would do. I'm not going to lie, I would probably do it too, particularly with that last one. Okay? There's just too many numbers there, I don't have to think about it, calculator does it for me. Why I bring this up is if we then go through and change it and say this is 3 meters over meters. Calculator's not going to tell you meters over meters. Okay? You have to do that interpretation. So when we go through and punch in the mathematics, there's a reason we teach you how to process the individual equations and simplify them without a calculator. Because at some point, it's not just numbers. It's numbers and units. Those units, we can't punch into the calculator. You have to process those independently. Okay? Where that can become more important, if we skip to the last one, I'm going to do a little bit of rearrangement. So this is the same as 3 times 4 over 16. Yes? Everyone okay with that?
Yes.
Why can we do that?
Just change change the numerator.
Okay. We can switch the order with multiplication and division. Okay, we're allowed to shift those around. The reason I did that, so now let's say our answer was 3. Now it's meters over meters squared. What does meters squared mean? Okay, area is a valid analysis, so I didn't want to go quite that far. It's the same as saying meters times meters. Why is that important? One of our meters cancels, and we'd be left with 3, careful, 1 over meters. Our red meter is where? Numerator or denominator? Denominator. Make sure you translate it into the end to being in the denominator. So be very careful with where your units show up. Okay? Make sense? Okay. So we're only going to make it more complicated because we're actually going to bring in real calculations as opposed to me making stuff up. So what we're going to do is try and convert some units. This method is typically known as dimensional analysis. Your textbook comes up with a couple other things. Call it unit analysis or factor label method. I have no idea what those terms mean. Dimensional analysis is the only one I've heard it referred to as. Okay? It's a big fancy word for not a whole lot of extra stuff. All we're trying to do is organize our calculations as succinctly as possible. So we'll start with the first one. How many inches are in 3 feet? Okay, 36. You all did that calculation in your head. Perfect, I like that. Okay, except what happens if you can't do it in your head? Okay, to use a calculator, you still have to set up the problem right. Okay, so what we have to do is do calculations that we're already comfortable with in our head and convert them into a mathematical notation or a mathematical format, so that we can then apply that format to every single problem, as opposed to attempting to do it in our head every single time. Because guaranteed, one way or another, you will get stumped if you try and do it in your head every single time. Okay, so what did you end up doing? How did you do that conversion?
3 feet times.
So I heard a 12 times 3. I'm going to switch the order around on that and say you actually did 3 times 12. What's the problem with that?
12 over 1.
Units. Must include the units. 3 what? Feet. Times 12 inches. Really? I do that math and what do I get? I get 36 feet inches.
12 inches over 1.
Our answer is just inches. So what did we miss?
1 foot equals 12 inches.
1 foot is 12 inches. This 12 is actually a conversion. It's a unit factor. Okay? It's not just 12 inches that you're multiplying by. You're saying that there are 12 inches equals 1 foot. Okay? If we take that mathematical equation, I should have drawn it below to begin with, and we divide both sides by 12 inches, we get 1 equals, whoops, I should do it the other direction. Let's divide both sides by 1 foot. We get 12 inches over 1 foot equals 1 foot over 1 foot. What's 1 foot divided by 1 foot? 1. What we just came up with is our unit factor. Okay, or our conversion factor. 12 inches over a foot equals 1. So if I want to convert 3 feet into inches, I want to multiply by some conversion factor that first off brings inches up into the numerator. Why do I want it in the numerator? Because our answer has it in the numerator. Ow. Has to be inches in our answer. And we need to somehow, incorporate the rest of that unit factor, which was 12 inches per 1 foot. Now when you go through and evaluate, what happens with your answer? The feet as units cancel out. And now we multiply 3 times 12. We get 36. And the letters that we can't do in the calculator, what are the only letters left? Inches. We've now got our conversion. So the idea is that you need to be able to do some of the calculations that you've already been doing in your head, that you've grown up with, and start to realize that what you've done is created your own unit factor. Okay? And it was nice for you because in the denominator, what was your number? 1. So it was an implied number that had no effect on the rest of the calculation. Okay? Depending on what you're working with, it may not be that simple. You may have to account for numbers in both places, which is why you've got to keep careful track of what you're using to convert. Okay? So when you write out your calculations, make sure you include those units. So let's see if we can make it a little bit more tricky, because you guys are laughing at me like that was really easy. Okay? So let's take a look at our unit analysis method. So what they're doing in your textbook is trying to break it up into your individual steps. What we're trying to do is target pretty much 3 different sections. Figure out what we're trying to get to as our end. So typically, when you would write out a problem, or at least the way I would do it, is I'd start off with my equals. Because that makes me feel better. I'm getting close to my answer, because my answer is right after that equals. Okay, what units did we want for our answer in this case? Inches. So I know some information about my answer. If I know it, I should write it down. Okay. What other information am I given? So now we can go back and say, okay, what other stuff do I have? I also know something about what I started with. So we can put what I started with up at the beginning. Okay. How I would process this is not try and then pull through, oh, what are all my unit factors? I switch it up a little bit differently. So what I go through and do is say, okay, I need to multiply something here. And this works at the simple level. When we track more units in, it becomes a little bit more difficult. I need to bring in some kind of conversion factor that allows me to get rid of the feet unit. So feet must be in the denominator so that it can cancel with the feet that I have in the numerator. And I also need inches in the numerator. Okay, now I'd pull back and say, okay, do I know of a conversion factor between inches and feet? You have that little faith in me. Yes, I know a conversion factor between inches and feet. What's that conversion? 12 inches is 1 foot. Okay. Now I'd go apparently it's still really early. I'd crunch through the calculations and see what happens with my units. I would ignore the math for the moment. My feet units will cancel, and I'd be left with inches. And I'd again reevaluate. Is that what I wanted as my answer? Just inches. Yep. Okay, now I'll punch it into the calculator. Okay? So the idea is to break it down into as many simple steps as possible. Okay, so at first, all we're going to do is just one conversion. Eventually, we're going to make it more complicated and start to bring in multiple conversions. That requires stringing together multiple different thoughts. It's a little bit more difficult, but I have faith that you guys are going to do awesome at it, because you guys think this part is boring. Okay, so let's pick an easier one. Whoop, yeah, sorry, my bad.
Question.
Yeah.
If that was feet squared and we're converting to inches squared, would the 12 be 144?
Yes, and we will cover that, I think, when we talk about volume, which I've added as slides that we might get to today, but will probably show up next week. Okay. It's one of the much more complex. We're trying to ease our way into it. Are you done looking at the slides? Okay. What is the mass in grams of a 325 milligram aspirin tablet? So if we break it down, where do we start? If you're an optimist. If you're a pessimist, you probably already left. Start with our equals. What's our answer going to be in? Grams. It's okay. Do we know anything to start with?
39.
We know we have 325 milligrams. Okay, at this point, we put down all of the information we're supplied, and we now have to think, okay, was this one of the conversions that I was told to memorize? M stands for milli. Is that one? Yeah. So you don't get any more help. You now have to pull back into your memory and try and come up with that. So personally, again, where I would start, times some conversion factor. And again, I'm being an optimist. I'm hoping I only have to do one. And my answer has grams where? Numerator, denominator? Numerator, which means my conversion factor better have grams up in the numerator. Is there a unit I want to get rid of? Milligrams. Where should that show up?
Thank you.
And our denominator. Now we'd have to pull back real hard and say, okay, is there a conversion factor between these two? Okay, yes. So depending on how we've memorized or used the chart, our chart would say 10 to the negative 3 grams is 1 milligram. Does anybody know a different conversion? One gram is 1,000 milligrams. It's effectively the same calculation. All we're doing is now converting that 10 to the minus 3 mathematically into the 1,000. Okay? It's again up to you how you exactly want to memorize that. I personally would try and figure out the relationship where I don't have to deal with that power of 10. Okay? Exponents scare me and the negatives scare me. I'm easily scared. Okay? You may laugh at me, but that's fine. That's the way it works. Yeah.
So I guess from that, you wouldn't be accepting of 325 times the negative 3 grams.
Good question, actually. So these are multiple choice. That is a really good question. So what he's asking is if we looked at our multiple choice answers on an exam, there are a couple different ways we could write this number. 325 times 10 to the minus 3. Okay. And grams. Okay. We could also go through and do varying calculations with this. We could say it's 32.5 times 10 to the minus 2 grams. Or, slippery pen, 3.25 times 10 to the minus 1 grams, or 0.325 grams. So on a multiple choice test, which of these answers would be correct? That's where it gets dangerous. All of these are technically correct. They all represent the exact same number. Okay. Which format would we choose? Okay, so I would say arguably 2 of these are valid and 2 are incorrect. Which 2 are correct? Pick our bottom 2. Okay. The difference between these two, first off, this one's in scientific notation. I can't spell scientific. Let's just say SN. I did spell that right, yes. SN, scientific notation. Why are the top 2 not in scientific notation? Our format was the decimal point needs to fall after the first sig fig. And both our top 2, that hasn't happened. Okay, they've shifted, that decimal point's been placed somewhere in between. Okay, between our 2 correct answers. Okay, trying to decide between those on a multiple choice test, first off, how many people would think I would ask that question? So little faith. No, I would not ask that question. Why would we choose one format over the other? I would argue it doesn't even have to do with that. Okay, think back to my personal fears. What did I like about exponents? Nothing. I hate exponents. Exponents scare me. Number 2, what do I like about negatives? Also don't like them. So if we compare these two numbers, this one has an exponent and a negative exponent. 2 signifiers that scare me personally. Okay? So why would I bother to include that when I could just as easily represent the number with actually less writing here? So a lot of the formatting on how we represent our answers comes back to the minimal amount of writing. If there were a bunch of extra zeros in between our leading zeros, we added a bunch in here, that's going to end up changing my exponent out to get technically smaller and smaller numbers. So -2, -3, -4. Okay. The threshold between when we decide to use scientific notation and when we use standard numbers pretty much comes down to how much effort you want to write. Scientific notation does require a couple extra symbols in small cases like this. But if we get to really small or really big numbers, the scientific notation requires less writing. Okay? That threshold is arbitrary. It depends on the person who wants to work with it. Okay? So when it comes to an exam, which of these 2 answers do you think would show up? Just the one on the left. I would also probably not ask or provide these first 2 answers. Okay? Sort of. This first one is probably fair. Second one I wouldn't provide. Okay, why? So they're still both valid answers, so it makes it a little bit trickier to manipulate. Okay? That first one I would say is not scientific notation any way you slice that. Okay, as far as where we've discussed it, which would then allow me to say you didn't actually process the full calculation. Okay, the intent is to see what does that translate through to. Okay? Other numbers that I could put in there?
0.33.
What happened in this case? You did the conversion wrong. Right? Instead of doing 10 to the minus 3 grams is 1 milligram, you said 1,000 grams is 1 milligram. That's how you would get that number. Okay? So right off the bat, you're going to get 2 very simple answers depending on how you set up your conversion. If you set up the conversion correctly, you've got your answer. If you set it up backwards, you get the wrong answer. That first one, like I said, I haven't quite decided on if I would include that as a real answer or not. Okay. Questions about that? Yes.
Are there some of these on the homework?
Yes. Should be. Pretty sure I did that. Other questions on it? Okay. What is the mass in micrograms of a 325 milligram aspirin tablet? So, where do we start? Yeah. Building some optimists in here. Equals. Equals what? What's our symbol for micrograms? Okay, it's a weird symbol. It's the Greek letter for M, at least on a keyboard. You switch to Greek and hit M, that's what you get. Okay. What other information do we have? We start with 325 milligrams. So I would again go through and try and process this. You'll notice I'm not being quite as optimistic here, and that's because I've had enough practice with this to know that I would mess this up. And I'd go through and attempt my first pass. Milligrams, comfortable with. That needs to cancel. Micrograms needs to show up on top. Okay, I like this conversion. Except, is there a conversion between micrograms and milligrams? Is there one readily available? Those of you that can do math in your head, don't answer. Okay, no, there's not one readily available. Okay, so that gets a little bit tricky. Is there some common conversion between the two? Is there a common element between micrograms and milligrams? Grams. So what we can do instead is say, instead of converting to micrograms, I can convert to grams. But then I know that micrograms can be related to grams. So I use that common element in between to help come up with a conversion factor between these two. So now what we're doing is stringing together two conversions. Still again, thankfully, only within the metric system. Okay, if this gets complex, don't worry, it gets even more complex when we bring in the English system. What's the conversion between grams and milligrams? So we've got 10 to the negative 3 grams is 1 milligram. What's the conversion between micrograms and grams? 10 to the negative 6 grams is 1 microgram. Okay? We could now track our units. And we go through and change our units. Our milligrams, numerator, denominator, numerator, denominator. What happens with the answer? We end up with micrograms. So our units are correct. And the next issue is, did we actually put the right numbers in? And that's something that you would have to memorize. Okay? We could then punch it into the calculator and get our overall answer. All right, I saw some questionable faces on that. Are there questions with this? Or are the questionable faces that this was too easy? Let's try that. Is this too easy? Hands up.
Honestly, I don't understand what you just did.
Okay, that's what I wanted to hear. So what we're, again, trying to do is come up with some way to string together enough conversions to get this across. Okay, so we write down the information that we've got. Okay, so all we're doing is specifying all of our, we start with grams. We start with milligrams. The whole goal in this whole process is to just convert the units. So the problem that we've got here is that our units are not what we wanted. Okay, so we have to somehow come up with some way to change that M to a micro, okay, or that weird Greek letter. Anybody know their Greek letters? What is that letter called?
Which one?
Mu. Thank you. Yeah, it is mu. Yes.
So when you want to say milligrams and micrograms, you just put mg for both.
Milligrams is M. Micrograms is mu. Yeah, so micrograms is not technically an M. It's a Greek letter, mu. Which I always thought was interesting. I never saw an M. I always saw U. Looks to me like a U, a cursive U. Well, don't make fun of how I see things. That's what I see. Okay, so you can make it a cursive M, if you will. Okay. So what we're trying to do is convert that little m into the symbol mu. So somehow or another, we have to go through the same process that we did already. Were you okay with the first process? Okay. So we could go through and put in our first pass. We want to get rid of the milligrams and introduce micrograms. Okay. Problem with that is, do you know a conversion? No. If you don't know that relationship, now it gets trickier. We have to come up with some other way to get that conversion across. So we'd have to think back, is there another relationship that I could relate these things to? Okay. Is there a common factor between them? And what is that common factor? Okay. So you see the common factor of grams? So now what we can say is, okay, I may not be able to directly convert between these two, but I can convert them to grams. So grams is the common relationship between the two. So if I can get it into grams, I can then shift it back into micrograms. Okay, so let's break this into two steps, which is something that's commonly done. So what we're going to say is, you know what, I don't like that long drawn out process I'm going to break it into 2 steps. I'm going to say I'm going to get it into grams first, because once it's in grams, I know I can convert it into micrograms. So we'll just do it as a single step here. What's the relationship between grams and milligrams? Okay. 10 to the negative 3 grams is 1 milligram. That's our Greek prefix conversion. Okay. If we follow our units, what happens? Milligrams cancel, and we'd be left with grams. We track that out as a number, we get 0.325 grams. Yes? Okay. So we could go back to our question. Does our question ask for grams? No, it asks for micrograms. So what we did was said, okay, I don't know how to get directly to micrograms, so I'm going to shift to something that I do know how to get to and hope that once I've got that, I can now go to the next problem. So what we'll do is now evaluate a new problem. We have 0.325 grams multiplied by some conversion factor has to equal micrograms. So now what we're going to do is go back through our same processing that we've been doing. We want to get rid of our gram unit, so that needs to go in the denominator, and our microgram unit needs to go in the numerator. Okay? What's that relationship?
1/10.
Okay. Now when we punch that into our calculator, we get our microgram conversion. Okay. So what we did was 2 conversions, but we broke them into multiple steps, as opposed to doing it all at once. Okay. It's up to you how you want to process it. As these conversions get longer, you're going to want to do it in one smooth step. So it's going to help to go through and practice probably both methods. If you're not comfortable with the first method where we had it in one step, break it into 2 or 3 as necessary, and then come back through and try and see if you can condense that into one step. Does that make more sense? Okay. And it is a difficult process to put together, particularly as we make it more complicated. So please ask now. Yes?
What's the difference between this method, dimensional analysis, and the, I don't know.
All the other names, they're all the same.
Well, there's acronym that I learned in the elementary education program where it says King Henry died drinking chocolate milk or something like that. And that's how you memorize all the like King would be kilos, Henry would be hecka, died would be deca, and then you would.
I have no idea.
You've never heard of that?
I've never heard of that. I can't answer that question.
Okay, yeah.
So what they're trying to do is help you with the places.
Right.
Okay, so that affects your number. Really what I want you to focus on here is not so much the number, but the unit. The number here is used to convert the unit. And in these cases, you may have seen alternate methods where you're doing just the decimal place shift. Okay? So you might have a way to memorize your decimal place shifts already. That's fine. But what happens if it's not a factor of 10? What if we want to convert inches into centimeters? King Henry's dying dog doesn't help us.
Then we remember longer.
Okay.
Longer line.
For that conversion, we don't even need a longer line. If we just want to convert inches into centimeters, anybody know that one? 2.54 centimeters in 1 inch. There's no factor of 10. What we need to be able to do is to manipulate the conversion, our units. Okay, so that's the big change from any other class that we're working with, or that you've seen probably so far, is that we're no longer concerned so much on the numbers. They do have to be right. But what we're concerned about is the units. How do those units allow us to do the conversions? Okay, so our units are telling us what numbers to use. In a case with mathematics, all you're looking at is a number. There's no units to give us any information behind it. So here, change your focus from just shifting a decimal point to focusing on what the unit is telling you. Okay, and that's the idea behind the unit conversions. With the conversions that we just looked at, you can do some other mathematical comparison because that's all that's happening. You're doing a decimal point shift. As soon as we shift into English conversions, you don't have that luxury. Okay, so you have to be more comfortable with these types of formatting. Amir, question.
Yeah, so the answer would be 0.
Oh, you're gonna make me do all that math?
Yeah.
So our answer comes out to be 0.00. Oh my gosh. Oh, whoops. Yeah, sorry. Let me look at it. Forgot which way we were doing. Micrograms, yeah. We got to go the other direction. Whoops. Eraser. 325,000 micrograms. Did I do that conversion right for those of you mathematically inclined? Okay, thank you. Okay. More questions on that? Can we slowly start piecing in more things and see if we can make it a little bit more complicated? Yeah.
Grams is on the left side, the zeros. But micrograms, they go on the right side. You know what I mean?
I think I know what you're saying, yes.
Yeah.
So micrograms
So the gram
are
is 0.
smaller
Yeah,
than...
so whichever is small goes this way. I mean, for the 0. Because the
When
question
coming
was
from a
like-
larger unit, yes.
So for example, you have like deca.
I think I know what you're trying to do, and I think it's going to get you into trouble.
Yes.
So track with the units. Because what you're trying to do is something that I try to do as well when I was doing it, and that comes back to the 60-70% of the time I was right. The other 30% of the time I was wrong. This way, odds are you're going to be up at like 99% right.
So let's express the units in, for example, here,
Mhm.
scientific notation.
So if we want the answer in scientific notation, is this answer in scientific notation?
No.
No. So now what we'd have to do is go back to the question that Thor had brought up when we looked at, I already forgot what problem we were looking at. I think that was the milligram one. If we want to now convert this answer into scientific notation, what do we have to do? 3.25. So we have to put the decimal point in front of or behind our first significant fig times 10 to, was it 5 really? 1, 2, 3, 4. Oh, you're right. 10 to the 5th micrograms.
So it's always between the first and the second.
Scientific notation is always between the first and the second, as far as we've discussed and you're concerned about. Hi? Other fun questions on that? You had a hand. Alejandro, right?
Technically, could we go like, instead of doing the 2, could we just do the 1 all the way across?
Yes. You'll get the exact same answer. So one more time. I know everybody's super excited for this, but let's do it one more time where we string it all together. So we can, again, write out the information we've got. 325 milligrams needs to go into micrograms. Okay, this is where we started with it, then we broke it down, and now we're going to put it back together. If we do this, same idea, we want to try and convert between milligrams and micrograms. This is why people don't like this method that I'm showing you right here. Do you know a conversion between milligrams and micrograms? We don't have an official conversion on that, so what has to happen? Now we have to find the common relationship between the two. That common relationship is grams. So what we can do is say, you know what, I'm going to convert to grams first. Then what I want to do is convert my grams. Why do I have to put the grams in the denominator? So it cancels the previous unit to micrograms. Okay. What I've done here is now strung both those calculations, or those unit conversions, into one calculation, one full line of calculation. Okay. For me, it's easier. For you, it may not be. So break it into multiple steps if you have to. Now you have to actually recall the numbers that are associated with these. We've got 10 to the negative 3 grams is 1 milligram. 10 to the negative 6 grams is 1 microgram. To calculate in the calculator, we could also go through and put a 1 over that first number. okay, to make this a little bit easier. So why do that? Well, what we can do is now say, in a calculator, 325 times 10 to the minus 3 times 1. We multiplied everything in the numerator. We get an answer. We then go through and divide that by our entire denominator, 1 times 10 to the minus 6. Do that final division, and now you've got your final answer. All right, and you'll end up with the exact same thing. Okay? Which was that 3.25 times 10 to the 5th. More questions on it? Should we try and move to a different example so we stop looking at 325? Okay. So unfortunately, so this is why I was saying we want to address these issues early, is that not everything is metric. Metric was nice because we can just shift decimal places. We're just accounting for those zeros. It shifts our digit over. Our numbers don't really change. It's just where those numbers show up in our sequence of decimal spots. Okay? So we could get away with King Henry died killing small rabbits. Okay? It's not very nice. King Henry died, those rabbits killed him. Okay? Yay for rabbits. So is everything metric? So this was the problem that I was trying to get you to realize back with the metric system. If we have to convert out of the metric system, it's not just those decimal places. We look at some of these conversions. Okay, if we want to convert, look at the English unit for length. Okay, one of our standard measurements is an inch. Well, 1 inch is not a factor of 10 relationship to centimeters. We have to come up with a new conversion factor. Okay, or a new unit factor. Same applies for pounds. Pounds is not a multiple for grams. We have this 454 number showing up. Okay? So these conversion factors are a lot more difficult to manipulate. Okay? King Henry becomes pretty useless. So what we've got to do is, again, do the same thing that we did before. Convert these line equations into a unit factor. Okay, or what I've been calling a conversion factor. So if we take a look at that first one, we said 1 inch equals 2.54 centimeters. How do we convert that into a conversion factor? Divide both sides by the same thing. Let's divide them both by 1 inch. Let's make that look like a 1. Oh, that was not a good choice. It looks a little bit better. Okay. Why is that helpful? I can now convert inches into centimeters by using that conversion factor. Because that equation right there equals what? 1. So when I multiply it by anything else, all I'm doing is multiplying by 1. Thankfully, it also goes through and changes my units for me. So mathematically, it doesn't change the meaning of our number. It just changes the units around. Okay, so we would get the exact same size, just a different unit of measure. We could go through and do that with all of our other ones as well. Okay, pounds into grams. We could go through and say 454 grams is 1 pound. There's that stupid 1 again. All right, and we now have that relationship. All right. Questions about that? Yes?
We expect to memorize conversion.
I was waiting for that one. I don't think so. When it comes to the English to metric conversions, I think what I'll do is include a cheat sheet at the very front of your exam booklet that'll have the ones that are a lot more than what you'll be using. So you would have to look at them and know which conversion to use.
Are these the only ones?
I don't know, you tell me. So there's a bunch of metric conversions. Anybody see anything about yards? What's it say at the bottom of the question? 1 yard is 0.914 meters. So there are a lot of different conversion factors with these. Almost all, or all of them are derived from these base units. We just have to scale differently and accordingly. Okay, so you could derive all of these conversion factors from the base ones you already know. Okay? Other questions with the English one so far? Because all we've done is just look at it. Okay, so let's go through and actually work with it. Erase. Still erase. Thank you. Okay. And before we actually work with that problem, I want to address one more thing. You notice that whole makes matters worse? Because they weren't bad enough, right? Right? They weren't bad enough? I guess they were bad enough. Make matters worse, what's the problem? Take a look at this footnote here. When applying these metric equivalents, assume 3 significant digits. Oh, crap. So now when we go through and deal with our conversion factors, they incorporate significant digits. What happened with our metric conversion factors? Do we need to worry about significant digits? No, why not? They were an exact measurement. There are 10 to the minus, oh man, my conversion's bad, 10 to the minus 3 meters in 1 millimeter. Right? That's an exact measurement. There's no sig fig issue. When we start changing units, okay, or changing unit systems, English versus metric, now we don't run into exact conversions. We have to be concerned about our significant digits, which can make a really big impact on your overall answer. So if you're going to do conversions with English to metric equivalents, what do you think is going to happen? How many significant digits should show up in your answer? No more than 3. So if you see an answer that has a whole lot more than that, okay, either you were given a different conversion factor or that answer is not valid. Make sense? Okay, so let's take a look at a problem. The length of an American football field, including the end zones, is 120 yards. What is the length in centimeters? So I picked this one for a couple reasons. Okay, you'll notice that I've given a whole bunch of extra conversions on top of the ones already given. And there's going to be a variety of ways that we can go through and convert this. So let's go ahead and start. Where do we want to start?
1 yard.
Okay, equals what? Centimeters. What did we start with? 120 yards. Okay. So our very first step, do we have a conversion between centimeters and yards? Okay, we could go back through and look at all of our relationships, and I don't see one there. Okay. Do we have a conversion to get yard into something else? Yeah. Okay, so what we're trying to do is find a common relationship between yards and centimeters. We don't have an obvious one, so then we evaluate all of the conversions that we do have. Okay? Sounds like almost all of you zeroed in on this last one. Okay. Why is that one helpful? Well, if I can convert a yard to a meter, am I now in my metric system to be able to convert to centimeters? Yeah. Okay, so what we'll do is go through and change our centimeter conversion to be just our meters. What's the relationship between those two? We've got 1 yard is equal to 0.914 meters. Okay. If we want to break it into multiple steps, we can. We can punch it into our calculator and get an answer. I don't like doing that, so unless there's an overwhelming vote that I break it into multiple steps, I'm going to run it as a string. Overwhelming vote? Okay, if you've got questions about it and want to see it in smaller steps, just talk to me after class. We're now in meters for our units. So we could even go back through and start to condense things out. So we can now keep a mental track of our units. Our units currently are meters. Can we convert meters to centimeters? Is there a relationship? So we'd again go through as effectively a new problem. Is there a relationship between meters and centimeters? Yes. What was our relationship?
100 centimeters is 1.
10 to the negative 2 meters is 1 centimeter. A few people have also shouted out 100 centimeters is 1 meter. Mathematically equivalent. The reason I'm doing the 10 to the negative 2 is that's how your table has it measured out. That's the only reason I'm using it, because I hate exponents and I hate negatives, but I want to be consistent with what you guys have in your textbook. If we now follow our units a second time, what happens? Our meters cancel, and we'd be left with centimeters as a unit. Is that what we want for our final answer? Yep. Now we can go through and punch it into the calculator. Again, how would I punch this into the calculator? I would treat the numerator as a whole piece and the denominator as a whole piece. And that's because multiplication and division are, communicative? Is that the word? Communicable? The order doesn't really matter unless we bring in, actually it doesn't even matter. So at no point does it matter with the order that we do it in. So I'm going to do all the multiplication in my numerator first. Then I'm going to take the denominator, do all the multiplication in the denominator to get a new answer. I will then divide at the very end, because that makes my life easier. It's up to you. If you don't like that, don't do that. Yes?
You do it the long way compared to feet, then do inches and then to centimeters.
So I was about to do in the next one.
Would that one be more exact? Or?
No, actually, so that's a good question as far as the accuracy goes. Can someone give me an answer on this?
109.
Okay, there shouldn't be that many different answers. 109.68. So that's what your calculator spit out. What's your actual answer? Ooh, this one's actually kind of tricky. So how many sig figs did you give me in your answer? 1, 2, 3, 4, 5 sig figs that you gave me in your answer. Are you allowed to keep all 5? No. So we now have to go back through and evaluate. How many sig figs were given in each of these conversions? I don't have a really good color for this. Purple. How many sig figs given in 120 yards? There's only 2. Why are there only 2? No decimal point. The next one has how many sig figs? 3. Next one. Infinite. It's an exact measurement. So in our answer, how many sig figs are we allowed to report? 2. Okay? So we would go through and say our sig figs are really only our 1 and our 0 here. Now we've got to evaluate rounding. Does rounding show up in this? We look to our first insignificant digit. Is that equal? 5 or greater? Yeah, 5 or greater? Yes. So what happens? We add 1 and we get for our answer. Did I do that right? Yeah. 11,000 centimeters. Questions on that? Isn't that fun? You had to go through, do your conversion, which was mind-boggling enough. Then you had to double back and go back and do all of your sig fig calculations on top of that calculation.
And how did you count the sig figs? Was it just the numerator or was it all of the stuff?
Everything.
Because I guess I'm confused because it right there shows
So-
4 because you're not counting that 1.
So this is a number. This is also a number.
I see.
These are 2 different things.
Okay.
Okay. Why does this one not count as 1 sig fig? Why is 1 yard not 1 sig fig? It says assume 3 sig figs in your conversions. Okay, so this 1 yard is not 1 sig fig, but actually 3 sig figs. Why do we not draw it out as 1.00? Rhymes with hazy?
Lazy.
Or lazy.
Hazy.
Okay. Questions about that?
Yes, and that's the infinite sign.
What's that?
And the infinite sign you said, right?
I did the infinite to represent how many sig figs are in that last one. Yep. And that's infinite because that is an exact measurement. There was another question floating over here.
Didn't you, well, in like multiplying across the numerator, don't you still technically have 10 to the negative 2 on the bottom?
I assume someone did that they did do that calculation for me. All of it's been done. I didn't break it into the individual steps.
So,
Here. If we're going to break it down mathematically, how I would enter it into the calculator, we would get 10 to the negative 2 on the bottom. Anybody can do real quickly for me? 120 times 0.914. What was it? 109?
0.68.
Oh, yeah. Now that I've multiplied the top and the bottom, now I'll go through and do the division. I do the division, and what happens? Now I get the 10968 number, centimeters. For our final answer, we convert that into 11,000 centimeters. Thanks for pointing out the skip step. Okay. We could also convert in a different fashion. How else could we have converted this?
2 feet, 2 inches, 2 centimeters.
Yup. And yeah, yuck was a good response on that too. Do we have another conversion between yards and something else? We could convert it to feet. 1 yard is 3 feet. Okay. If we go all the way up to the top, I do have an inch to centimeter relationship. So if I can convert my feet into inches, I can then convert my inches into centimeters. So 2.54 centimeters and 1 inch gives me, hopefully, darn close to the same answer. Okay. What we're going to have to watch out for is we've run more calculations. More calculations where these are all exact. This one's exact, technically exact as well. Still comes out to 2 sig figs. We should get the same answer. What we'd have to be careful of is the more calculations you do, the more potential that you incorporate a sig fig issue, and you have to watch for that calculation. So ideally, you do as minimal calculations as possible, so you don't have to worry about rounding errors as you go through and do it. Anybody punch that in? Tell me what you get. Okay. Really, really close to our last number. Okay, but you'll notice, is it exactly the same? No. And that comes back to the conversions. The conversions that you used to go through and do this. The 2.54 is an exact measurement according to our table. The 12 inches to 1 foot and 3 feet to 1 yard are also exact. Whereas in our previous calculation, our 1 yard to 0.914 meters was not an exact measurement. Okay? So that extra conversion or that different conversion changed our end result by a little bit. Does it affect our overall answer? No. How do you know? How many sig figs do we have in this answer? Still 2 coming from our 120. Everything else was exact. So our infinite sig figs. And we still end up with an answer as 11,000. Yes?
So, how did we know to take 2 sig figs? I understand
So we-
that has 2 sig figs, but I don't understand.
When you do multiplication, how does it work?
No one's pleased.
Nope. You got to remember your rules. When you do multiplication, how do you translate your sig figs? The least number. This one has 2 sig figs. So our first step, what happens to our sig figs? Infinite and 2. 2 sig figs carries through our first step. Second step, 2 sig figs versus infinite. How many sig figs translate through to our next calculation? 2. Move to our next calculation. 2 sig figs versus infinite. What carries through? 2. Okay? So what we want to do is make sure that at each of those steps that we also don't round. Okay? I will leave that for you to actually do. If you go through and round at 2 sig figs for each answer all the way through, see how that affects your end answer. Okay? And you should see an even more substantial change than just the unit conversions. So you want to make sure that when you round your answers with sig figs, you do that at the very end of your calculations. And you'll notice it is a bit troublesome. You have to stepwise through each calculation and make sure that you're translating your sig figs separately, okay, at the very end. More questions on that? You happy with that? When are we done? We're done at 40? Ooh, I think I want to stop. I still got a couple minutes. I think I can finish this part, because this is just an extra addition here. Compound units, okay, which is ultimately another conversion factor. What are the units for your speed, for your car, your bike? Okay, we're looking at least in our English system, we're looking at miles per hour. This is yet another conversion factor. This allows us to convert hours or a time into miles. Okay, so if you walked here, whoops, let's multiply this out. Come up with a couple different ways. Give me a number for your speed. 65. You were clearly driving, hopefully. 65 miles per hour. Okay, that's typically how we would write it. We might also see it as 65 miles per hour. It's a better way to come up with that, in my opinion. It is 65 miles in 1 hour. Why shift to this format, our last option? That really gives us a clear delineation between our unit conversion. It's 65 miles in 1 hour. We have a very clear numerator and a very clear denominator. Right? It allows us to then manipulate our mathematical equations later on in those two spaces. If we look at our other formats, it's very easy to get confused on where that miles per hour should show up, okay? Particularly the second one. In that situation, where does it look like the hours are shown? Okay? The most common mistake is to say that miles per hour is in the numerator. The miles are in the numerator, the hours are in the denominator. Okay? Why address this? Because we now have another way to convert. Okay? How do we use this miles per hour? It takes you 20 minutes to, or let's say, I started with 20 hours to get here. Can you figure out how far you went? Yeah. How did you do that? You do 20 hours times your 65 miles per hour. Your hour units cancel, and you're left with miles. Okay? What if you went 60 miles? Okay, and we'll still say we're sticking with 65 miles per hour. How do we do this conversion? How long did it take you? Do we have a conversion factor that relates hours to miles? What's that conversion factor? 1 hour, 65 miles. We now have how long it took to get here. Okay? We'll come back to compound units and work with that a little bit more next week.